Okay, so here's the second table. And so these are primes when you square them. Sorry, when I take the non-primes, n, 1, 2, 3, 4, 5, this time up to 25, I look at n squared, and I look at the prime, look at that number modulo a prime. So tell me what you see in this table.
Well,
Why don't you describe what you noticed mod 3 for the primes?
Well, I see pattern of 1 1 0 1 1 0 1 1 0 1 1 0 1 1. It keeps going.
All right. So does that tell you what does that tell you about primes mod 3?
They're always either 0 or 1 mod 3.
Okay. So what's a number? Is that all the numbers mod 3?
No.
No, because so if you had a number that was like 1 mod 3, and you squared it, you'd get another number with 1 mod 3.
Okay.
If you had a number that was 2 mod 3, you square it, you get a number that's 4 mod 3, which is 1 mod 3.
Okay. Very
And the
good.
number with 0 mod 3 just stays at 0.
Okay.
And so every third number, you have one that is 0 mod 3.
Okay.
Mm-hmm.
Why don't you pick a line, pick whatever one you want, and tell me something about that line.
Well, let's look mod 11.
Okay.
So it goes, you have 1 4 9, 5 3 3, 5 9 4, and then, so we're definitely not getting some numbers.
Okay. Very good. So we don't always get all the numbers.
So I think in this case,
Here, use probably better to use a pen if you want to write something.
so I think for mod 11 we're not getting, let's see, we've got 0 1, we don't seem to be getting 2. We get 3 4 5. We don't seem to be getting a 6. Or a 7. Or an 8. We have a 9 and we don't seem to be getting a 10.
Okay.
So we seem to be missing those numbers.
All right. The other question is, was that on camera or not? Was my finger on camera?
Barely.
Okay. Let's tilt that just a little bit. All right. All right. So we didn't get all the numbers in mod 11 either. That's interesting.
So I'm gonna make a guess that if we go and look at each and every one of these, we're not gonna get all of our numbers.
Okay. That's a good guess. Is there a number we always seem to get?
Well, 1's pretty obvious.
Okay. Why do you think we get a 1?
Because 1 squared is always 1.
Ah, 1 squared is always 1. Okay.
That's always going to be 1 mod anything.
Okay.
And it's also, I mean, I guess as the mods get bigger, the small squares will always be here because like if we look at mod 47, because you can go 1, 4, 9, 16, 27, 36 are all less than 47.
Oh, okay. Great observation.
And those will be in 47 and in all of your mods after 47 too.
Cool. All right. Anything else you want to say, or anything else you noticed here?
Well, not sure if this relates to anything. Let's see. I see 16, 9, 4, 1, and 0, and then 1, 4, 9, 16 again.
Oh.
And that's in the 19 row.
Should I circle that?
19.
Good.
There.
Okay, so sometimes we see the squares counting down and then counting back up again.
It also looks like we're seeing 0 less and less frequently.
Ooh, okay, interesting. Well, we always see 0.
Yes.
Why?
Because if the mod, like here for 47 squared, you'll get 0 mod 47.
Okay.
But I guess as the mods get bigger, 0 is going to appear less and less frequently.
Uh-huh.
So I guess we're not seeing it on this table here.
Is there ever a prime where we'll see lots of zeros?
Well, a small prime is generally where we'll see more zeros.
Okay. How will we see a 0 modulo a prime? Will a prime ever be a square?
No.
No. Okay. So the zeros we see are only going to be when we look mod prime.
And we see the prime squared or a multiple of that prime squared.
Yeah. Okay. All right. So for our last project, we're going to look at a very specific number, and see
All right.
how often we see it. Okay.